Here's how you can protect email the same way you protect crypto. Using a hardware wallet, you can export public keys while safely storing the private keys offline. The public keys can generate email addresses. This one uses the Bech32M address scheme, the same as Bitcoin. Then the service, Address.pub, stores public keys. When you upload a public key, a new email account is created for you. That email account can be used like any other account to register different services. When a sender wants to transmit mail to you, here's what normally happens. They establish a transport encryption session using TLS with your mail server. When they pass the message into your mail server, your system administrators can see it, any malware, viruses inside the mail server can see it, and anyone who's managed to gain access to your mailbox can see this message, which means while you sleep, someone could request a password reset, have it sent to your mailbox, they see it, they gain access to your account. This is not a good way to do things. Our service uses secure enclaves to change the paradigm. These secure enclaves give us cryptographic integrity guarantees that the code executing inside the enclave is unmodified. They also have hardware entropy sources. We don't need a regular mail server. In fact, all we need is a pass-through server to relay TCP packets into our secure enclave. That means our servers are no different from any other untrusted hop along the internet. Your mail lands in the safety of our secure enclave, which we cannot see. Inside the enclave, a random key is generated to encrypt your message. Then the corresponding public key is fetched from our database. That is used to encrypt the random key. Now this encrypted payload can be shipped off to storage. Since it's fully encrypted, the storage could be public, like a blockchain. Users have a computer and a hardware wallet, so they use their computer to fetch the encrypted payload. They send part of it off to the hardware wallet, where they will physically accept the decryption request, which means the hardware wallet can reveal that one-time use random key that was generated inside of the enclave. That can be exported to the computer, where the message is decrypted. What can we see as the operators of Address.pub? Not much, because an important property of the secure enclave is that we cannot see into it. We can push the code, we can be guaranteed that our code is executing in the enclave, but we have no ability to snoop this message. We can't see the memory, we can't access the compute unit, it's just a black box to us. We can see the establishment of a TCP session that we relay into the secure enclave because it's just traffic over the network. Then we can see that a public key is fetched from our database and an encrypted payload pops out to storage. We'll also see that a user fetches the encrypted payload, but beyond that, we don't even know if this user can decrypt the message. Address.pub launched in January. We have an app that runs on a Ledger Nano S hardware wallet. The app is installed manually via Ledger Tools. We also have a cross-platform command line interface that can be used to register new addresses, fetch mail, and decrypt the mail. We'll be releasing a new round of invitations later this month. You can visit Address.pub to request an invite if you haven't already received one. This summer, we plan to launch multi-party integrity guarantees. In this scenario, you'll be able to have multiple keys. You could say, we require 2 of 3 hardware wallets to be present to decrypt a message. We'll also undergo the Ledger app audit process so that our app will be installable via Ledger Live. And later this year, we will launch custom domains.